This video covers Part 2 of Lesson 2-10 for Secondary 1 Math, Writing and Graphing Linear and Exponential Equations. The current population of a city is 40,000 people and is increasing 0.8% every year. Let x represent the number of years and y represent the current population after x years. Number 10. Write the equation for the current population after x years. So notice our population, or current population of our city, is 40,000. So this would be our initial amount, A. Then we're increasing 0.8% every year. So this is going to be our R. And written as a decimal, we're going to have 0.008. And then we're going to let x represent the number of years, so there's our time, and y would represent our current population after x years. Since we're increasing by some percentage, we're actually going to be using the exponential growth form, which is y equals a times 1 plus r raised to the xth power. So now I can just substitute in the values that we know. So our equation for number 10 would be y equals 40,000, our initial value, times 1 plus 0.008 raised to the xth power. Or we can write this equation by simplifying inside the parentheses as y equals 40,000 times 1.008 raised to the xth power. Okay. Number 11. Predict the population after 7.8 years. So here we're just going to substitute in 7.8 for x. So if I substitute it into our equation, we would have y is equal to 40,000 times 1.008 raised to the 7.8th power. When we substitute in our calculator, we get 42,564.95, which then we need to round to the nearest whole. So we would say that it would be 42,565 people. Next, Riley has 500 free tickets to pass out at a conference. After 4 hours, he has 188 tickets left. Let H represent the number of hours and Y represent the number of tickets Riley has left after H hours. Number 12. Assuming that he is passing out tickets at a constant rate, what is the slope? So this is referring back to a linear equation or a linear situation. So using what slope is, let's set up an expression to represent it. We have the change in y over the change in x. Now notice the change in y represents the number of tickets Riley has. So it changed from 500 to 180. So if we subtract those two, we'll find out how much it changed. Then our time started at 0 and went to 4, so our change is 4, so 4 hours. So I take the 500 minus 188, and we get 312. And we stay with 4 in the denominator. And we can simplify this by taking 312, dividing it by 4, which gives us 78. So our slope, we would think, is 78. But if we look closer here, notice it says let H represent the number of hours and Y represent the number of tickets Riley has left. So if Riley started with 500 tickets, we actually have to subtract 78 every hour to determine how many tickets Riley still has. Number 13. What is the Y-intercept? Well, that's what we start with, or what Riley starts with, and Riley had 500 free tickets, so 500. Now we're going to write our equation to represent the number of tickets Riley has left after H hours. So we're going to write y equals our slope, which is negative 78, times x plus 500. which is our initial value or y-intercept. Our next situation. A bowl has 80 Skittles. 20% of the Skittles are disappearing per minute. Let X represent the number of minutes. Number 15. What is the initial value? So in this situation, we notice that we have a bowl that has 80 Skittles. So our initial value is 80. Number 16. What is the rate of decay? Well, our rate, it says that 20% of the Skittles are disappearing per minute. So our rate is 0.2 or 20%. Number 17. What is the decay factor? Remember, the factor is represented by b. But when we write this equation in exponential decay form, we actually replace b with 1 minus r. So we're going to take 1 and subtract our r, which is 0.2. 1 minus 0.2 is equal to 0.8. And so our decay factor is 0.8. Now to write this in an equation, we're going to go y equals our initial value 80 times, we can use our decay factor 0.8 raised to the xth power. Number 19, we want to make a table and then graph. So we're just going to use that equation that we had from number 18, which is y equals 80 times 0.8 raised to the xth power. And we're just going to substitute in the different values of x in our table. So first we'd substitute in 0. This is my favorite one because it always comes out to be the initial value, which is 80 in this case. And then we can substitute in 2. So this means we're going to take 80, we're going to multiply it by 0.8 raised to the second power. And when we simplify this and round to our nearest Skittle, we get 51 Skittles. Then again, we're going to repeat this process. We're going to take 80, we're going to multiply it by 0.8, we're going to raise it to the fourth power. Remember in our calculators, that's the carry symbol, then the 4. And we end up with 33 Skittles when we round. Now I'm going to repeat that process. So go ahead, pause the video, substitute in 6, 8, 10, 12, 14, 16 for x, and evaluate to find y, the number of Skittles. So your table should look something like this. For 0 minutes, 80 Skittles. 2 minutes, 51 Skittles. 4 minutes, 33 Skittles. 6 minutes, 21 Skittles. And so on. Now we're going to take these values and we're going to graph them. So we're going to plot them on this coordinate plane. Remember, we got to label our x and y axes. So our x-axis will be minutes. Our y-axis is going to be Skittles. And then we're just going to plot these points. 0, 80 will be our first, so we're going to place that up here, 0, 80. And then we're going to continue by plotting 2, 51. So I go over to 2, up to 51, and put a point. Then we plot 4, 33, so over 4, up to 33. And then you have 6, 21, and 8, 13. And then we have 10, 9, 12, 6, 14, 4, and 16, 2. And we've graphed our situation. Number 20. At how many minutes does this equation not make sense? Explain your answer in a complete sentence. Looking back at our table, we'll notice that it's decreasing, decreasing, decreasing. It's getting smaller, smaller, smaller. And they may not be something that's glaringly obvious to us. There's going to be an issue or when this equation won't make sense. But if we take a little bit closer look, so go to the 1, so the digits in between, so maybe starting at 12, let's go ahead and look on our second page. If x is 12, then 13, and then 14, and we substitute these into our equation, So this is our y equals 80 times 0.8 to the xth power. We end up with some y values. And let's look at these and not round them so much. Let's round to the nearest tenth maybe. So we got y is equal to, we got 80 times 0.8 raised to the 12th power, which is 5.5. And we rounded that up to 6 in our table. Then we go y equals 80 times 0.8 raised to the 13th power, which would give us 4.4. That's fine. That's at least a skittle different. And if we put in the 14, we get y equals 80 times 0.8 raised to the 14th power. And this results in giving us 3.5. And here, we're actually losing less than 1 skittle. And we can't lose less than 1 skittle. It's impossible. Right? It's starting to not make sense here. So your answers may vary in answering this, and there's probably a lot of different things that we could put down. Okay? But I'm going to say at about 13 minutes, you start losing less than 1 skittle, which doesn't make sense. This concludes the Part 2 video of Lesson 2-10, covering problems 10 through 20 in Secondary 1 Math, writing and graphing linear and exponential equations.